the situation given to us is that A will always try to move straight towards B. B will always try to move straight towards C. And C will always try to move straight towards A. Let us analyze the motion by moving them slightly, one by one. Let us say that A moves towards B, and B moves towards C, and C towards A. So at this time, the new positions of A, B and C will be like this. And note that, due to the symmetry of the motion, the new positions of A, B and C will again form an equilateral triangle. Again, A moves towards B, B towards C, and C towards A. Repeating this process over and over again, we can say that they should meet somewhere in the center, which in case of the equilateral triangle will be the centroid. And we can intuitively say that their motion will be something like this. Note that, though the actual movement of A, B and C is complicated, but if we look at only two of the particles, we can say that at any instant, A is always moving straight towards B, and B is always moving at an angle of 60 degrees with respect to this direction. So according to A, their relative situation is always the same. If we resolve the velocity of B in components along and perpendicular to this direction, we can say that since along this direction they are approaching each other with velocity equal to v plus v cos 60, and their initial distance was equal to d, so they should meet in the time equal to d upon v plus v cos 60, which comes out to be equal to 2d upon 3v. Note that if instead of a triangle there were four particles on the corners of a square, and we have the same condition that A always moves straight towards B, B towards C, C towards D, and D towards A, then using our approach, we will see that the motion will be like this. Again, if we focus on the motion of two particles, we can say that at every instant A will see B moving like this, so their relative velocity of approach will be equal to v, and thus the time taken to meet should be equal to d upon v. What can we say about a general case of n particles on the vertices of an n-sided polygon moving with the same constraint? If we consider only the two particles, we can say that their relative velocity will be equal to v minus v cos of this angle, where this angle is the exterior angle of the polygon, as we know that the sum of the exterior angles of any polygon is equal to 2 pi. Therefore, each exterior angle is equal to 2 pi by n for an n-sided polygon. Therefore, the relative velocity of approach will be equal to v minus v cos of 2 pi n, and hence the time taken should be equal to d upon v into 1 minus cos of 2 pi by n. As an exercise, you should validate this formula for a triangle, square, and also for a hexagon.